we left off here. This question says, find the function f of x whose derivative is sine x and whose graph passes the point 0,2. Okay? So, what do we need to do? You don't just reread the problem, please. Well, this we need to find the function. Yeah, f of x thing. But do we take the derivative of sine?
No.
No. We need to find a function when we take the derivative of it. That's sine. So basically, there is some function f of x where if I take the derivative of it, that would equal sine of x. Okay? We'll worry about the points in a moment. What was it? How did you figure that out? Right. Let me explain what he said. You were right. You are right. Yeah, I know you were. You were right there. I saw it on your face, your lips, you're like... So if I take the derivative of cosine, that's negative sine, right?
Yeah.
The derivative... Yeah, there you go. The derivative, it's terrible. It's negative sine. But I want sine to be positive. So how about I take the derivative of negative cosine, and that will make it positive. All right? Because let's remember our constant rule, I guess. If I have cosine times a negative, that's really a negative 1. If I want to take the derivative of this, let's take the negative 1 out here, take the derivative of cosine, which is sine, and then apply the negative 1 back into it. Okay? Well, actually, this is negative sine, and then I apply the negative 1 back into it, which will give me a positive sine. Okay? That's just the backward thinking it takes when we're working backward with derivatives. All right? So, my function here, we just found out, has to be negative cos of x. That would give me sine of x, I want the derivative, right? Now, quick question, is there anything else you can think of that would give me any function that I have here that would give me a derivative of sine of x? It's a lot simpler than you think. Don't start throwing in other trig functions, that's not going to do it.
Itself.
So you're telling me negative cosine of x is the only thing that I can take the derivative of and get sine of x. When I show you this, you're going to be like, oh, well, you're going to be like, we knew that, Visca. You do know it.
Perfect exact.
What if I take the derivative of negative cos of x, we know that's going to give us sine x, right? What if I take the derivative of negative cosine of x plus 2? Yeah, see, it's terrible. That would give me sine of x. What if I take the derivative of negative cosine of x minus 11? That would give me sine of x, wouldn't it? Because the constants go to 0, don't they? The constants go to, yeah, the constants go to 0. So, when we work backward, we don't just say that, well, in order to get this derivative, my function has to be this. My function has to be this, plus there might be some constant. I don't know what it is. Well, the constant could be negative. That's what we call it, okay? In this case, we can have a constant be 0. It could be negative cosine, that's it. But we don't know. All I know is, if I have negative cosine x plus c, it's some constant, that has to give me sine of x when I take the derivative, right? Even if that constant c is a 0, it still gives me sine of x's derivative. Now enters this. Not only do they want the function whose derivative is sine of x, but they want it so that that function passes to the point 0, 2. So here we go. You ready? Thank you for that vote of confidence. We currently have my function is negative cos of x plus some constants. So where do the 0 and 2 come into play? That's a coordinate. That's x and y. Or in our case, it's x and f of x. Isn't that the same thing as y? Now I can solve for c. I can actually find the exact equation. Whether it's plus 2, minus 3, plus 5, whatever. Maybe it's plus or minus 0. So I say 2 equals negative cos of 0 plus c. What is the cosine of 0?
1.
It's 1. If we use degrees, but we use radians in here. What is it? Everything in here is always radians. So what's the cosine of 0 radians at 0 degrees?
0.
0 is still 0. It's still 1. Don't forget. Yeah, it's still 1. 0 is still 0, no matter what it is. It's 1. So this is what? Negative 1. Because cosine of 0 is 1. So 2 equals negative 1 plus c. So what's c?
3.
C is 3. When I add 1 to both sides, I get 3 equals c. And now I have my c value, and now I have the exact function. My f of x equals negative cos of x plus 3. That goes through the point 0, 2. That goes through the point 0, 2. And its derivative is sine of x. There you go. So not only do you got to go backward, yeah, but you get some information to find out what that c is. Anytime you go backward, you always put a plus c. Because you never know. Because you never know if you get a constant and just turn the 0 into a derivative. Okay? The process of finding the original function from the derivative is so important in calc that it has a name. It's the antiderivative. Don't worry, you guys are doing something profound. It's just anti what we're doing. Okay? It's the antiderivative. Okay? Just like we did that problem, we had sine of x would have been the derivative. We had to go backward to find that original function that gave us the derivative of sine of x. It was negative cosine. All right? That's called the antiderivative. Okay? Now the function f of x is an antiderivative of the function f of x. Notice one is capital and one is not. Okay? If the derivative of the function is equal to f of x for all of x in the domain of f, the process of finding the antiderivative is anti-differentiation. I have told you guys, derivatives is called differentiation, so antiderivatives is called anti-differentiation. You will hear much more about antiderivatives in the future. This section is just an intro. Yeah. I love looks in all your faces. Find the velocity and position equations for a downward acceleration of 9.8 meters per second squared. And an initial velocity of 1 meter per second downward. We are going to assume that velocity to be a positive 1, even though it's accelerating downward for the sake of this problem. So, what do we do? What do we have? What piece of information do they have for us?
They gave us acceleration.
They gave us acceleration. Acceleration is 9.8. Okay? Now, they want us to find the velocity and the position. Well, I know velocity is the what of acceleration? Antiderivative. Good. So I've got to work backward. So what is the equation or function for velocity to where if I take the derivative of it, it'll give me 9.8. No, it's good to say. You should know this, right? It's 9.8, but we're going to use t for time. T. Isn't it? Isn't it? It's 9.8t. Because if I take the derivative of 9.8t, it just becomes 9.8. Good. But what's the one thing I say we always got to do? Plus c, because I don't know if this constant is 0. Maybe it is. Maybe it's -1, maybe it's +2, I don't know. But guess what I have to figure that out? What do they tell me? The initial velocity of 1. Okay? So, if my velocity is 1, well, I still need t in order to find out what c is. Can anyone figure out what t might be? Why is it 0? It is. Initial. That means start. You always start at time 0. Nice. Nice. So, when I do this, yeah, that was a belated clap, but it was still a clap. Okay? What happens here? Bam. C equals 1 for velocity. So my new velocity equation to satisfy time 0 velocity 1 is 9.8t plus my c value, which is 1. That is velocity right there. That is velocity. But we still need what? What's the other thing we need? We need the position equation. Okay? We need the position equation. Alright? Position is what? Compared to what? What is position? It's the antiderivative of velocity. Okay? Notice we're just working backward here. So, if I have velocity equals 9.8t plus 1, okay? I can find position by going backwards, working backwards. Okay? Now, careful, because this one seems easy. What would give me 1? Well, x, in this case, t. Because we're going to but yeah, this would give me t in my position. Yes. Well, what do I take the derivative of to get 9.8t? How did you figure out that it was 4.9t squared? Okay. This is great. This is nice. Holy cow! I thought this was going to take us a lot longer. Maybe I'm holding you guys back. Maybe it's me. I'm just a terrible teacher. Now listen. Let's think the way the exponent rule works. Okay? I want you guys to pay attention. Okay? Okay? Let's think of the way the exponent rule works. Hold on. Pay attention. If I have 3x squared, and I want to take the derivative of it, not the antiderivative, but the derivative. What do? Yeah. Okay. I multiply by the exponent, right? And then what do after I bring my exponent down? Then I subtract 1 from the exponent, right? So this is the process for the derivative. The antiderivative, not only is it the opposite math, but it's in the opposite order. Okay? So to do the antiderivative, first of all, what is the derivative of this? 6x, right? So how do I find the antiderivative of 6x? Not only do I do, right, like I said, the opposite math, but in the opposite order. I add 1 to the exponent first, and then I divide by that new exponent. So what does that mean? I have 6x, well, 1 plus 1 would be 2, and then I divide by 2, which would be 3x squared. Look at that. Okay? It's just backwards. Not only in math, but in the order of the math you do. Everything's backward. Okay? Word. So now take here, 9.8t was, you said was what?
4.9t squared.
And there's a plus here. And how did I figure that out? Or how did you figure that out? Or how can we figure that out now? It's because if I take 9.8t and I use my antiderivative thing here, I add 1 to the exponent, so this becomes 2. and then I divide by that exponent. 9.8 divided by 2? I mean, you guys got the exponent rule so quick. For a funny thing, multiplication and addition everybody can do. The minute you turn to subtraction and division, well, people fold and crumble. Okay? But are we done? Thank you. Because I'm going to get rid of this right now. And there's one thing that we forgot in our antiderivative. Plus C. Well, that was to find the velocity constant. And now we got a constant. Because if I take the derivative of this, I'll get this. Well, I could have any constant here, because that goes to 0. But how do I know what number, like for velocity, the initial velocity was 1. So at time 0, velocity is 1. Here there's an assumption they're making that they didn't tell you. We're assuming that you're starting at position 0 at time 0. They should have stated that in the question, they didn't. Okay? Remember, position is like a number line. It can go negatives, it can go positives. But we're going to assume that this starts at 0 right in the middle at time 0. So initially. So that means at 0 for t is 0. That's position. We're going to assume that. So that means we're going to be at 0 at time 0. So what is C? C is 0. C is 0. So C is 0. I'll plug my 0 in there, which means I can only just lop that off. So my position, 4.9 t squared plus 1. And if we really, plus t. If we really want to check this, well, what's the derivative of position? It actually is this, which is velocity. And it works out. And what's the derivative of velocity? It's actually this. And it works out absolutely perfect. Yeah, good. I like to hear OICs.